This video is for the domain and range of real-world situations involving exponential functions. So our word problem, Patricia won $5,000 from a lottery ticket. She invested the money in an annuity that earns 7.5% annual interest, compounded annually. The function b of x equals 5,000 times 1.075, where x is the number of years, shows the balance of Patricia's account, b of x, in dollars, and is graphed to the right. So a quick little thing about exponential functions. If we're talking about growth, so 7.5% as a decimal is 0.075. So to get your b value here, when it's growth, so when it's growing, we're going to add that to 1, and that is called the growth rate. The rate is 7.5%, and we add the growth rate to 1. So if we had something that was decreasing by 50%, okay, as a decimal, that would be 0.5. So to get, so this would be called the decay rate. And so to get the b value, we would do 1 minus 0.5. So in this case, our b value would be 0.5. But say it was 75%, which was 0.75, we would do 1 minus 75 hundredths, and our b value would be 25 hundredths. So that's how you're getting this b value here. Just kind of a quick, this is an Algebra 1, quick little review there. All right, so identify the real-world portion of the graph. So first, what are we talking about here? Our x's is going to be the time in years, and our y is going to be the account balance, the money, in dollars. So time is never going to be negative, so we're going to start where time is 0. Okay? So the real world portion of the graph starts at where x is 0, and then it's going to continue on this way. So any values that are on the negative side of x are not going to be valid in the real world. And so that value right there is going to be 0, 5,000, and that's our y-intercept. So that's our minimum x and y value right here is our y-intercept. Okay, so now the domain and range. So when we're talking about just the function, the entire function itself, the domain is going to be all real numbers. So mathematically, with the equation, in an interval notation, negative infinity to positive infinity, in equality notation, x is a member of the set of all real numbers, and in set notation, it would be the same. Okay. Now our range, so again, looking at just the function, this function here is never going to be less than 0. The range will never be less than 0. So mathematically, the range is all real numbers greater than 0. So from 0 to infinity, y is going to be greater than 0, and y is a member of the set of all real numbers where y is greater than 0. So mathematically, that's our domain and range. But when we're talking about real world, things change a little bit. So the reasonable domain for this situation, the independent variable x represents the time in years. Time must be positive and could be restricted to whole numbers, since the interest is compounded annually. So we could just say we're only going to use the x values of 0, 1, 2, 3, 4, and so on. So verbally, all whole numbers is our domain. So in interval notation, that's from 0 to infinity. In inequality, x is a member of the set of whole numbers. And then set notation looks the same. All right, so the reasonable range. The dependent variable, which is our b of x, represents the account balance. The balance must be greater than 5,000 because that's our starting point. We're never going to have less than 5,000 in that account. And if the domain is restricted to whole numbers, the range will be restricted to a set of certain real numbers. Okay? So, and honestly, it will be more rational than anything else, because, and it will be rational numbers rounded to the hundredths place, because in money we only have two numbers after the decimal. So verbally, we're going to say all real numbers greater than or equal to 5,000. So in interval notation, we're going to start at 5,000 because it's going to be equal to 5,000. So that's why we're using the bracket to infinity. This could go on and on forever. As an inequality, y is greater than or equal to 5,000. And in set notation, y is a member of the set of real numbers where y equals 5,000, so it's going to equal the original function, 7.5 to the x, where x is a member of the set of whole numbers. Meaning that we can only put whole numbers in for this x. And whatever values we get out, those are going to be our only range values. All right, so to wrap this all up, compare and contrast the mathematical domain and range of b and x, of b of x, and the reasonable domain and range of b of x as the function models this situation. All right, so the mathematical domain of b of x is all real numbers. The reasonable domain as b of x models the situation is a subset of the mathematical domain. So whole numbers are a subset of real numbers, meaning the reasonable domain is a subset of the mathematical domain. The situation also restricts the domain to all real numbers greater than or equal to 0. The situation could also be interpreted to restrict the domain to whole numbers. The mathematical range of b of x is all real numbers greater than 0. The reasonable range as b of x models the situation is a subset of the mathematical range of b of x. The situation also restricts the range to all real numbers greater than or equal to 5,000.